Let's start. Hello, I'm Michalis Argiriou, Head of Architecture Development SWOT. Today I will talk about uncertainty and projects. First, allow me to introduce you to my company. SWOT Group was established 20 years ago. We have more than 1,000 clients in 50 countries and more than 2,300 people. You can see our business expertise on the bottom left and some of our clients. For example, NASA uses GRC, a risk management system that we develop. UEFA uses Venue, an event management system. And we also provide IT services to European, international organizations, agencies, and companies. Let's now focus on Greece. Greece entity was established in 2016. It is part of Benelux and Spain. We have one office in Athens and 280 people. We're focused in the United Nations and European Union agencies and organizations, as you see, European Patent Office, the TAXU, the ASO, ESMA, EULISA, and others. Therefore, typically, our projects are constrained by time. Our business is triggered by regulation, so it's not easy to not meet deadlines. This is a typical project. It is triggered by client specs. Typically, developers develop the project. Every project can be modeled with three components: source, process, and sync. Source, for example, can be a mobile app or a single-page application. Process can be a microservice per se, and sync can be a database. What can go wrong? Nothing, of course. For developers, we're optimistic. But the truth is that everything can go wrong. As you can see, I will use the bug icon whenever there's a problem. Allow me to summarize the presentation in one slide and allow me to read it. Software projects are threatened by late and unexpected complexity introduced due to uncertainty and conjunction fallacies. Complexity must be embraced, fallacies must be identified and avoided. Keep the keywords complexity, uncertainty, and fallacies. Uncertainty is related to complexity, as you see on the left side of the slide. On the x-axis is technology uncertainty. We don't know the technology, or we think that we know it, or technology may change. On the x-axis are requirements uncertainty. Requirements are not finalized or may change. So if uncertainty is high, we have anarchy. If uncertainty is low, we have simple projects. There is also a hidden axis, let's call it the z-axis, about people uncertainty. Complexity, according to the mythical month, can be partitioned into essential complexity and accidental complexity. Essential complexity is inherent to the project. For example, a form with two input text is more complex than one with one input text. Here, we will try to minimize accidental complexity that is due to fallacies, due to uncertainty. Let me now delve into the three dimensions of uncertainty and start with requirement uncertainty. Baseline fallacy. The client provides the specs. The problem is that the specs are not reviewed, are not finalized, are not signed. We don't have a baseline, as we say. Typically, the client knows what they want us to develop. It is in the regulation. They know what, about how, and how it fits in the enterprise architecture. For the ones that know TOGAF, this means that they have spent once the ADM method. According to the cone of uncertainty, this is from project management, uncertainty is minimized with time. For example, Waterfall has one sprint, one iteration, but Agile has multiple sprints. That's why Agile handles uncertainty better. As we see in the Stacy complexity model, Kanban is proposed when uncertainty is high, Agile when uncertainty is mid, and Waterfall when uncertainty is low. So taking this insight, we conclude the following. What we have tried in some of our projects. Combine Agile and Waterfall. Time box analysis with Waterfall. So minimize uncertainty from chaotic to Agile to complex, and identify what you can deliver until the deadline, the must requirements at least, and then manage construction with Agile, with Scrum. How architecture fits here. Early decisions in architecture have high impact. Architects are perfectionists, they refuse to take decisions until they have the full information. But sometimes we don't have the full information. So either we should not take decisions or take decisions that can be reverted. A methodological approach, according to the books on the right, is find a fitness function for the architecture. For example, how many requirements you meet to reach the architecture goal. do incremental changes that bring you closer to the goal, and minimize architecture and expect that the data model will change. But consider that some things cannot change. For example, if you start with a microservice architecture, it cannot change to serverless. Also, according to the principle of the run less software, use boring technology. This means technology that you know, that you're expert, and you're productive. Don't experiment with uncertainty is high. Some examples. We have a client which is a very mature DG. They want us to do waterfall analysis and construction with Agile. This goes very well. We have another client in UN. We started with waterfall. The problem is that they request all the time change requests. We said this cannot go anymore. We time box analysis into 2 months, waterfall, and then we change construction with Agile. And we'll go into production mid-October. Now, dimension 2, people uncertainty. Don't take people for granted. Productivity will be increased fallacy. This is typically a fallacy of the developers, mainly of the architects that provide the initial effort estimation when a project starts. But the truth is, as we saw the last 2 years, that there was a great resignation wave. The turnover was very high, and some people even want to change careers. In order for teams to be productive, they should be together. According to the technical stages, they should reach the performance phase. So expect that people will leave unprepared. What we propose in order for teams to be productive? Faster onboarding, increase batch factor, faster to perform phase, and reduce noise. A reminder for all of you that do not know what batch factor is. Batch factor is how many people from a team a batch should kill in order to have a problem. This batch factor is 1, this means you have a bottleneck. Someone knows too much. And some proposals that we have tried, create droppable local environments. For example, we use Docker Compose in some projects, or Tilt, when we need local Kubernetes environments. Peer developers, something that we try is to pair junior developers with more senior developers in the same project as mentors. Self-service documentation, this is very important for onboarding. By the way, onboarding documentation should contain business information. Have developer portal in the company on the projects. Foster culture of freedom, responsibility and accountability. Set up a team agreement in the projects. For example, for the branching model, for clean code, for everything. Set up a surgical team. And this is again for a mythical man month. And it says put your best people on the best opportunities. For example, proof of concepts. Avoid meetings fatigue. This is something new. People are all the time in the meetings instead of writing code. Give responsibility, ownership to people so that only these should join meetings. Use a dedicated Scrum Master to protect the teams from the PM. Dimension 3, technology uncertainty. Single bullet fallacy. This can be a fallacy of the client, and then there's a big problem of the developer. As we see again from the book that I mentioned, there is not a single bullet. The truth is that combination of tools consists of a single bullet. But be careful, don't use overlapping tools for the same job. For example, one problem that we face, Pandas is used for data analytics. People believe that it's a single bullet. The client came and told us, do a SaaS migration using Pandas, or he stayed with Flow and deployed in Kubernetes. When we told the client, do you want us to check Spark? They said, no, I don't understand why you speak for Spark when I ask for Pandas. We went to production and we realized that the memory consumption was very high. Why did this happen? Because Pandas loads everything into memory. Cloud portability fallacy. The bad icon is on the hosting, on the outer box. The truth is that architects were obsessed with principles on portability. We try everything to be portable. But sometimes it's very costly. It doesn't worth making everything portable, especially when migrating to the cloud. There are low chances that you will change cloud provider. As one client once said, if a cloud provider is big, there's not a matter of portability. So embrace the cloud, but be careful, use open standards. Example, we have a greenfield project in Amazon. We have the choice to use EC2 and set up Kubernetes, or use Amazon EKS, which is the Kubernetes version of Amazon, or use ECS, which is an Amazon flavor of Amazon, and Fargate. We prefer the second approach because ECS is much simpler, but uses Docker Compose, so it uses standards. And Fargate auto-manages its 2 instances, so operations OpEx is very simple. Likewise, CloudWatch for observability, the 3 pillars, it's much simpler because out of the box it works with ECS. If we had to set up this manually, we would have to use Grafana, Prometheus, Kibana, Elasticsearch, and Jaeger, which are very, very complex. Hype-driven development fallacy. I have colleagues that tell me, let's go and learn Go, let's go and learn Rust. Okay, these are sexy, but you cannot become expert using polyglot languages and technologies. Okay, microservices are polyglot, but this is not sufficient, this is not sustainable. You will not find enough people on Go, people will come and leave, and you will have a fragmentation technology. Don't do it. Moreover, new technologies may reach end of life soon. You see here the Gartner hype cycle that says that shows the innovation life cycle. So there is a hype, and at some point, some technologies survive and reach the plateau of productivity. So our proposal is use boring technology again, wait until the technology matures, but become expert on these technologies. This is the green circle on the right. Examples. In Spring Sword, we use only a few technologies, but we are very good at them. 80% of our activities are on Spring Boot, React, and a few other technologies. Distributed computing fallacies. This comes from Sun. You remember Sun. They are still valid and will be valid in 10 years. Allow me to read them. Network is reliable, latency is 0, bandwidth is infinite, network is secure, topology doesn't change, there is one administrator, transport port is 0, the network is homogeneous. Let me show you a few examples that we have faced. Network is reliable. Has anyone wondered why the big cloud providers use 3 availability zones? Always. For example, Amazon, 3 zones. Google, 3 zones. Microsoft in Greece, 3 zones. Amazon in Greece, 3 zones. Google comes, will create 3 zones. Why? Let me tell you what is split plane problem if you don't know it. Assume you have component C, let's say a database, in a master-slave topology. Writes are submitting the master node. Assume that there is a timeout between the master and the slave node. Data replicated for availability. So we believe that C master is down and we promote C slave to master. So at the end we have 2 master and there is a divergence, so this is not sufficient. And this is called split-brain problem. The solution to this is that the master nodes should be flow nodes in the class divided by 2 plus 1. The code down is from Zookeeper, how it identifies if we should have a quorum. This is applicable to systems that need quorum and the replication is synchronous. Examples from our clients who have a European agency that uses 2 regions, who have deployed Zookeeper. We know there will be a split-brain problem. We are preparing a 3rd region. We have another client in UN who have a multi-AZ deployment, but they use only 2 AZ. They don't have an intention to get a 3rd availability zone. But they know that the problem exists. And by the way, this is applicable also to other systems like MongoDB, Cassandra, that use quorum to promote to nodes, to master. We have another client for you when we use event sourcing and CQRS. We write Kafka and we create materialized views in Elasticsearch and Postgres. The problem with Kafka is it provides only exactly one semantics when you read to Kafka and write to Kafka. When you write to Elasticsearch or materialized views, you have at least one delivery semantics. This means to process twice the same message. In order to resolve this, we use Flink. Flink rewrites the SQL queries to make them dependent, as I showed down there. So dependency is one solution. Fallacy 2, latency 0. Try to have all the components collocated. For example, both in EU and UN. When a message arrives into one region or into one availability zone, it is processed there and it doesn't leave it. For example, if a microservice always contacts the closer database instead of forwarding the message to the other availability zone or the region. Fallacy 5, topology doesn't change. As we saw this summer, availability zones went down due to high temperature. This has happened again, even the whole regions have gone down in the big cloud providers. So expect that even regions and availability zones will go down. Solutions for availability that we have tried. everything should be disposable. For example, Helm scripts, Ansible scripts, database instances, have databases with Postgres with a witness using EDB, or Elasticsearch. Microservices are stateless and they're disposable. Service discovery is dynamic. We don't usually hard-coded URLs. This can happen in regions. Assume that they are disposable, so use replication. Fallacy 6, there is one administrator. We had an interesting feasibility study for a European agency. Security at rest is easy. Just encrypt volume data or use TTE for databases. Encryption in transit is easy. Use TLS or encryption. In use is difficult. This means when I process data, data should be encrypted. So the solution that we checked, we included in a feasibility study, is using enclaves. Enclaves is a part in the CPU where data are decrypted, only there. The key is in the firmware of the CPU. So any administrator can access the data. This requires specific CPUs like Intel SGX. On the right side of the slide, I have online solutions like IBM Data Cloud Stream, Asino for GCP or AWS Net Enclaves, and I have some solutions for vendors for on-premises clouds. Configuration management. When something changes in an environment, it should be trackable. Ignore CI/CD, reduce GitOps for a European agency. Developer, Action and DevOps submits a pull request in big bucket. For example, a replica should be 3 instead of 2. Argo CD is triggered with a webhook. It triggers Helm and just executed and Kubernetes is updated. But everything is tracked in Git. Here I present a catalog of solutions for all the problems. I will let you 30 seconds to read them. I think this is the last slide. Okay. So one question for you, maybe you can answer to me using the mobile app, if you have faced any uncertainty and how you have resolved it. Thank you.